Okay students, this video is on example 24. Solve the equation 4 sin 2 theta minus 3 cos 2 theta equals to 3 for theta in between 0 to 360 degree. First we must understand what is the question trying to ask us. The question says solve. So the meaning of solve, at the end you must give the value of theta. The unknown in this given equation is theta. Okay, this is the first thing that you must understand. Now, second thing, when we want to find theta, please take note that the given trigo is not the same term. One is sine, one is cos. So, you need to express this as either sine 2 theta or cos 2 theta to be able to solve. When we want to state 4 sin 2 theta minus 3 cos 2 theta as either sine or cos, we're going to use the formula that we have learned here. So this question is about sine minus cos. Okay, so the first formula here is cos plus minus sine. Okay, the second formula is sine. Notice that down here we have minus cos. That means we're going to use Rsin. For minus, this is theta minus alpha. Okay, so we have decided for example 24 to express this as Rsin or Rcos, we're going to use Rsin theta minus alpha. Okay, so we're going to write here for sin 2 theta minus 3 cos 2 theta equals to, we have decided we're going to use the formula sine theta minus alpha. Okay, so we have to be extremely careful here. The given question is on 2 theta. Notice that the given question is on 2 theta, but the formula is about theta. Okay, so we need to modify the formula. Since we are looking for 2 theta, this cannot be theta minus alpha. It has to be 2 theta minus alpha. Okay, next we're going to expand sine 2 theta minus alpha using the compound angle. So we will be getting here sine 2 theta cos alpha minus cos 2 theta sine alpha. Okay students, once we have expand this, we're going to compare sine 2 theta with sine 2 theta. So when we compare, we can write 4 sine 2 theta equals to R sine 2 theta cos alpha. And we're going to compare cos 2 theta with cos 2 theta. Notice that the sign is the same. So I can write this as 3 cos 2 theta equals to R cos 2 theta sine alpha. Next, we're going to simplify this. Okay, we're going to divide the whole expression with sine 2 theta and we will be getting R cos alpha equals to 4, equation 1. And here we're going to divide by cos 2 theta. So we will be getting R sine alpha equals to 3 as equation 2. Okay, so we need to find R and alpha. To find R, we will take equation 1 square plus 2 square. So equation 1, R square cos square alpha, equation 2, R square sine square alpha equals to, on the right hand side, equation 1 4 square and equation 2 3 square. Okay, so now we're gonna factorize R square. So we will be having cos square alpha plus sine square alpha. On the right hand side, 4 square plus 3 square, we will be getting 9 plus 16, which will give us 25. So finally, R is plus minus square root of 25 or plus minus 5. Since R is greater than 0, R is 5. Okay students, so we already get the value of R. Next, we're going to find the value of alpha. To find the value of alpha, okay, we're going to take equation 2 divide by equation 1. So equation 2, r sin alpha divide by r cos alpha equals to 3 divide by 4. So now when we have r divide by r, we will be getting 1, and sin alpha divide by cos alpha, we will be getting tangent alpha equals to 3 over 4, and alpha is 36.87 degree. Okay, so we managed to find r and alpha. Next, we are supposed to express 4 sin 2 theta minus 3 cos 2 theta as r sin 2 theta minus alpha. So, at the question, okay, I'm going to write down here 4 sin 2 theta minus 3 cos 2 theta. We are going to express this as r. So, r is 5. R sin 2 theta minus alpha. Alpha is 36.87 degree. Now, we haven't done the solution. We have just done the first part of the question, which is express sine minus cos in terms of sine, so that we will be able to find the solution. Now, remember student, we are looking for the solution for 4 sin 2 theta minus 3 cos 2 theta equals to 3. So, we're going to write 5, since we managed to express this as sine, 5 sin 2 theta minus 36.87 degree. We're going to equate this with 3, because 4 sin 2 theta minus 3 cos 2 theta equals to 3. Therefore, the 5 sin 2 theta minus 36.87 will also equals to 3, because our aim here is to find theta. Next, we're going to transfer the 5 to the right hand side, so that we only have sine on the left hand side. So, sin 2 theta minus 36.87 degree will be giving us 3 over 5. So, remember students, we cannot straight away continue and find theta. We have to consider that theta is not in the same range. Okay, in the question, the given range is from 0 to 360 degree. But what we are looking for is not theta. What we are looking for is 2 theta. The question has given us range for theta. So, we're going to copy down the range of theta, and then we're going to modify this by multiplying with 0 and minus with 36.87 degree. So, the new range will be negative 36.87 degree up to 2 theta minus 36.87 degree up to 683.13 degree. Now, this is really important that you find your new range. Now, after we find the new range, we're going to continue with finding the suitable quadrant. Okay, now let's check for sign positive. Since this is positive, 3 over 5 is positive. Sign positive, we will have angles in the first and the second quadrant. Okay, which belong to all and sine. Okay, so we will have angles in these two quadrants. Okay, so before we find the angle, we need to find the reference angle. Sine alpha is 3 over 5. Therefore, alpha is 36.87 degree. Okay, now remember, we are not looking for alpha. We are looking for 2 theta minus 36.87 degree. Okay, we're going to start with negative 36.87. So, this will be negative 36.87, and we will continue the rotation until 683. Okay, students. So, for the negative 36.87, it falls on the fourth quadrant. So, we do not have any answer there. So, we're going to start with the first quadrant with the reference angle here, which is 36.87. So our first answer is 36.87, followed by the next angle will be in the second quadrant. Okay, so second quadrant, this is our reference angle, 180 minus 36.87 degree. Okay, we will continue to find the angle until we reach 683.13. Now we have done for the first and second quadrant. So next we're going to continue. There's no angle in the third and fourth quadrant, and we will continue with the second rotation. Okay, we're going to check whether is there an angle in the first quadrant. Okay, if there is an angle in the first quadrant, so one whole turn rotation will be 360 degree, plus with the first quadrant here is your reference angle, which is 36.87 degree. Now this angle is still in the range, so we're gonna continue. Okay, we have fulfilled one whole turn. Now we are on the second turn, and we have to stop at the second quadrant, because from the beginning we have decided we have angle in the first and the second quadrant. Now to get this angle, one whole turn is 360, and semicircle here is 180, and we need to minus with the reference angle 36.87, so that you get the angle that falls on the second quadrant after two whole rotation. Okay, now we're going to continue. Okay, let's say we're going to find another angle. One whole rotation will be 360. The next angle we have to rotate until the end, and if there's an angle it will be in the first quadrant only. But two rotation has exceeded 683. Therefore, we do not have any more angles, so we're going to stop here. Okay, so we're going to find out 2 theta minus 36.87 degree. The first answer is 36.87 degree. 180 minus 36.87 degree, we will be getting 143.13 degree, followed by 396.87 degree, and the last answer 503.13 degree. Okay, students, remember we need to find theta. So we need to add each and every angle with 36.87, and we need to divide each and every angle with 2. So for the first angle, the answer will be 36.87, followed by 90, followed by 216.87, and the last answer is 270. As we find the new range for 2 theta minus 36.87, all the answers for 2 theta minus 36.87 will be in the new range. Now, when you find the final answer for theta, okay, all your answer must be in the range given for theta. So the range given for theta is 360. So notice that all our answers are within the given range. Okay, so that's the solution for example 24. Okay students, so that's the end video for solve A sin plus minus B cos theta by using R sin theta or R cos theta. So I hope all of you have obtained the second learning outcome. See you all in my next video for the third learning outcome. Determine the maximum and minimum values of trigonometric expressions in the form of A sin theta plus minus B cos theta.